Let's do contains duplicate. Given an integer array, return true if any value appears at least twice in the array, and return false if every element is distinct. So just as let's look at the examples. In this first one, you got 1 at the beginning and end. So there's that twice, so return true. This one, 1, 2, 3, 4, there's 4 of them, return false. This last one is also true, and notice you can have more than 2 of an element, and you can also have multiple elements that have duplicates. So there's 3 3s, 2 4s, 2 2s, and we still just return true. So this problem is pretty simple, but we can add some depth to the discussion. It's a nice way to illustrate the trade-off between time and space. So there's two kind of common solutions that you can deal with. One of them is like sorting and doing a linear search. So that one, if you sort it, that's O of n log n time. But since you're sorting the input in place, it's constant space. Since you're not using any like extra space, you're just using the input memory itself. It's kind of finagly, but that's the way to do it. The other option is to use a hash set for linear time to make the hash set, and then another, also linear space for the set itself. So you can have a little bit more runtime and use less memory, or you can have a little bit faster runtime and use more memory. So those are some nice options, and this is a good illustration of that. So I'll go ahead and write out them both. I'll start with this first one, or sorry, the second one with the hash set, because it's pretty fast to write out. You're going to use in C++, it's called unordered set. Make sure you use the unordered one because that one's hash based, as opposed to the ordered one, which is I think a tree based, so you'll end up with logarithmic operations instead of constant. So yeah, make sure unordered set of integers. I'm just going to call it my set for lack of a better name, and we're going to use the constructor and just feed it nums, the beginning and ending iterators. And then this will populate the whole set with all the values of nums. And then from there, we want to return true if there are duplicates and false if there aren't. So since it's a hash set, that means anytime you try to add a duplicate, it's basically going to have no effect. So the size of our set will be smaller if there are any duplicates. So we want to return true if there are duplicates. So return, let's go, my set size. Realistically, it's never going to be bigger than nums. So if it's less than the length of nums, then we return true. And if it's equal, then it's going to be false for no duplicates. So that should do it. I'm going to give that a run for syntax just to show you that I'm not crazy. Yeah, see, so that works perfectly fine. The other option with the linear search, so the way you do that is you sort nums in place. So sort nums begin and end. It's sorted, so this is most comparison based sorting. So like merge sort, the quintessential one, are going to be n log n. Even quick sort is actually n squared time in the worst case. But on average, it tends to be n log n, maybe a little bit faster. It depends on the language implementation. It's usually a pretty safe assumption to make that sorting is just n log n, whatever algorithm the language tends to choose. But since this is C++, I don't think your interviewer is really going to question if it uses a good sorting implementation. They're just gonna they'll probably assume it's a fast one because that's that's the whole selling point of C++. All right, so we've got our sorted nums array, and then we're gonna do a linear search. So for int I equals 1, because we're gonna compare neighbors. I is less than nums dot size, and then increment, and then we write out the loop. So if nums I minus 1 is equal to, then we're going to return true. And then if that never happens through the whole loop, we'll return false. Yeah, okay, so sorting, and then linear search. We're checking immediate neighbors. If there's any immediate neighbors, since we've sorted, we know they'll be clustered together because, as you saw in this one and also this one, these are unsorted arrays. The equal values could be anywhere. So this will ensure they're next to each other. This is still linear time in case, there's one duplicate and it's the biggest item. So linear time and so linear time for the search and log n time for the sorting. This is what dominates. So this is our runtime. I'll go ahead and run that just to show you. Yeah, see, and that works as well. Yeah, so this is a nice little showing of the trade-off between time and space. And I think that'll be it. That'll do it. Let's go ahead and submit. I suppose I could have submit with the other one too, but that's fine. And then we're going to mark it off. And you guys have a great night. Thanks.